So with the graphing, again, by this stage in their schooling career, it should be pretty straightforward, but there are a few common mistakes students make. So they should have all their descriptive statistics and in a table and in a summary, and now we put them in a graph. And so that's what they have to have by the end of this lesson. Before we get into it though, I like them to talk about what's the purpose of a graph, right? So why are they showing this? And because I feel like sometimes this is missing, this is why there's not a lot of transfer. Students, this year, all my students wanted to do line graphs for things where a line graph was completely irrelevant. And I realized that they do that a lot in biology. They use line graphs all the time in their biology classes, just the nature of their experiments. But they're not thinking about the why of the graph, they're just doing it. And so if we know the why, what's the purpose, they're going to be able to do a better job of it. So these are I would say the common types of graphs they're going to use. And the most common type would be a bar graph or a histogram. And then we talk about what are the qualities of an accurate graph or qualities of a good graph. So hopefully they are coming up with things like, well-labeled axes, not misleading axes, things like that. All right, and then this is just time for them to create. So we can find an online graph maker. Yeah, they're easily found online. I'm not sure. I think I put a link in the unit plan for one. I would say that each group member should create their own graph. Anything that goes in the body of the report, as a general rule of thumb, if it's going in the body of the report, the students should have written it and made it themselves. Things in the appendices can be shared collaboratively, right? But anything in the body should be theirs. The one exception for the appendices would be the inferential statistics calculations. I want them all to do that themselves. They'll come out identical. They should come out identical, but I still want them to do that by themselves. I might just show them after they have a chance to make their own graphs, and I sort of walk around the classroom and I have a look, and I might see some common errors, and then we talk about what we've seen, and then I might show a couple of these slides, because this is one thing I see all the time in first draft graphs. Students, they want to show the effect. And so they do this with their axes, and we have to talk about that, right? The purpose of the graph is to show the result. So if there's not a big difference, they can't make it look like there is one. That's misleading. And so we talk about misleading graphs. And so here are some common errors to avoid. And so this is essentially working at like a checklist. Towards the end of the lesson, they can look and go, all right, I've got a title, great. I've labeled my axes, good. My axes are accurate. I haven't got heaps of graphs. Yeah, so that they can just serve as a checklist. All right, and then what I would do here for homework, I get them to read ahead in the textbook or in the handout that I provided in the files about hypotheses and inferential stats. Get them reading ahead about this because it is a pretty tricky thing to do. So if they come prepared with a little bit of background about inferential statistics, it might help. And that's what we're going to tackle next.